My name is Joe Millham, and I am a HVAC design engineer in the Chicago, Illinois office of WSP. And I was on the design team for this McDonald's project. And presenting with me is Mohammad Abbasi, who was the building performance analyst and consultant on this project, who helped optimize the building's design for net zero and helped us make sure our design got to the goal we were trying to reach. So for today's presentation, we will be discussing these are the points that we're looking to be walking through. First, why we worked on the project, and then how we ended up where we did, where this McDonald's landed, and then the different strategies and techniques that we use to go through the process. McDonald's set out a couple years ago to lower their environmental impact across their entire business line, and in doing so signed on to the Science-Based Targets Initiative, which is a multi-industry program that uses science-based facts and sets realistic targets for different industries based on their particular usages and operations to help lower their greenhouse gas emissions, electricity demand, water usage. McDonald's, in their examination of this process, came up with 5 main impact areas, ranging from working with their suppliers for all their different food products and packaging materials and reducing those impacts on the environment, to their transportation and their water usage, to their energy usage in their real estate portfolio, ranging from their offices to even their restaurants. Our project was part of this climate action impact area as part of the real estate portfolio, and they decided they wanted to make an example project that would be a way to show that you could achieve net zero using in a real fast food restaurant application. So as part of that, they chose an existing McDonald's location that they used that was located in the Epcot municipality outside of Orlando, Florida. This is the municipality or township area that houses both Disney World and all the other Florida Disney theme parks. And then this McDonald's is a standalone operator within that township that uses, has a very high profile location. It hosts large groups and people coming there for vacation. This was a good location for McDonald's because it was a corporately owned restaurant, which means that they could bring to bear their resources from their main offices here up in the Chicago area, and also they could have a lot of control over the design impacts and making sure that they met all of their targets, and not having to go and partner with a franchisee to do that. Also, one of the nice pieces about this was that it was located inside the township that is Epcot, which is focused very closely on life safety, but allows a lot of range in terms of design in order to meet life safety goals. But if you're trying to hit a very good user experience, Mickey, when he's your building official, is all for supporting that type of experience.
So this was not an easy project. I mean, it had a lot of complication, and as a result of that, we have to give a big kudos to all the teams that have been involved in the process, the architect, the owner, all the consultant, kitchen consultant, PV consultant, and the local team that delivered the job at the end. WSP was hired by Ross Barney Architects in Chicago that had experience of designing McDonald's flagship in Chicago as well to deliver energy, sustainability, and MEP design through DD. And after that, we were also hired by CPH, a regional firm that's been delivering hundreds of McDonald's design for the client to continue the energy analysis through the end. So the biggest challenge for the job was we have a building with the existing building. So we had a chance of like working on an existing building and knowing how much exactly the building is using energy. So how much PV generation we have to have on site, and what are the efficiencies that we have to consider to take to the net zero goal. So definitely achieving the net zero goal was the hardest and the biggest challenge in the job. And we not only used the data from the current project, we also looked into the other sub-meter data from the other McDonald's restaurants around the nation that have been provided to us by McDonald's and helped us understand the performance of every single kitchen equipment and be able to compare that to what potentially we're going to have here. I mean, and also other than that, we asked for a ton of data on like what are the transactions, how many people are doing dining, how many people are going to have a drive-through. And the chart that you see here shows that from over 1 million kilowatt hour annual energy use, we have started to build an energy model from the concept phase and understand with upgrading the kitchen equipment, improving envelope and shading with the air source VRF, implementing heat recovery and natural ventilation analysis. What are the strategies and optimization that we need that when we get to our last energy cost measure, we are close to what we can potentially provide on site for the renewable energies. And this is the exercise that we did in the concept phase before even just diving into the detailed energy analysis. And these numbers changed through the design till the end, but it remained consistent in the way that this been our approach to just make a building with high energy use intensity with EUI of over 500 make it to net zero. I mean, this building, even compared to other labs and healthcare projects, has a big energy use. And other than that, the other big challenge, especially for the energy side, was that we couldn't use any of the default templates that usually we use from ASHRAE Handbook of Fundamental. As I mentioned, the occupancy of the building, this is a 24/7 high use project, but it's still the biggest challenge, other than the fact that it has a lot of energy use, was variable occupancy, variable schedule, and the different use of kitchen equipment. And again, using those sub-meter data from other McDonald's projects that have been provided to us and the existing project help us to understand the performance of the project and doing a more accurate, predictable energy modeling.
So one of the big focuses, obviously, when you're trying to go for net zero is to reduce the overall loading on the system so that you don't have to make up as much of your energy with on-site renewables. So for this project, we were working with the architects, we came up with this large canopied roof system, as can be seen here in this section of the building, that acts as both a base for the photovoltaic solar cells on the roof, but also acts as a roof over the occupied space, which is inside this gray box here, and acts as a shade for the outdoor dining space on the side that is shown here in this bottom right picture, and also acts as a shade over the mechanical equipment to protect that and lower the heat gain on the rooftop equipment. This large shade also creates a nice little microclimate that allows us to push a lot of the occupancy out, and for people that are coming in, getting their food, they can move out to the outdoor space and eat outdoors where we don't have to heat or cool their space. This PV canopy also cools the space underneath there and allows us to take advantage of that air for a very aggressive natural ventilation strategy, where we opened the windows, and by opening the windows on the walls, we use these Jalusi windows, they're called, or Miami windows sometimes. They are slats all along the perimeter of the building that would, when opened, we would also engage some exhaust fans located up here on the roof, and we would draw fresh air that is probably a little cooler than the regular outdoor air temperature, draw it across occupants and out through the roof, so that people walking and sitting inside can feel a breeze on their skin that makes them feel cooler without having to turn on actual air conditioning. And it's a much lower energy use for a large portion of the hours of the year. This natural ventilation also acts as a means for makeup air on the kitchen equipment. So when you're cooking a lot of fries and hamburgers, you need to exhaust those fumes and that smoke. And so, and in order to maintain a normal pressure on the building, you have to make up that air. Normally, this is highly conditioned. A lot of fan energy goes into making up that air. And so using the natural ventilation process, we got to bypass a lot of that, and that takes out a lot of the consumed energy that we had modeled. But on those days, this being Orlando can get hot and humid. We were also sometimes require some cooling and some heating even during the middle of the night or in the winter. So we also installed an air source variable refrigerant flow system, which is one of the highest efficiency mechanical systems on the market. We worked with Trane, who's a longtime vendor partner of McDonald's Corporation, to use their latest version. They were actually coming out with a new iteration of their Trane products at the time that this was going into construction. So we were able to utilize their latest technology to achieve the highest efficiencies in the market for the cooling system itself.
So as Joe mentioned, I mean, this project was designed to have indoor-outdoor activity, and this was designed pre-pandemic. But as you can tell, having the indoor-outdoor activities and spaces designed to be comfortable, it came to make a huge role during the pandemic. This project was opened during the pandemic, and operational dining area was closed, but the outdoor area made a huge role. And we did some analysis, like using the different shades to help the client to understand how, with different shading strategies, how outdoor comfort can be optimized. This is an area that has a high solar gain, so provide shading made a huge role of helping that. But one thing that we have to mention, that including and using building integrated photovoltaic panels, the BIPV panels help to still bring some diffuse light to the space and not totally block the solar gain to the space. So we've been able, with the use of BIPV panels, we've been able to generate some energy over the outdoor area, the outdoor dining area, but at the same time, we still had good, sufficient diffuse daylight in the space. Joe elaborated on how important was for the architect, the client, and us to optimize the natural ventilation in the project. As a part of our energy analysis, we have created different scenarios to understand. The chart that you see at the bottom here, it shows that one of the scenarios that we use to simulate the building without the HVAC system to figure out in what hours we are within the comfort range, include considering the relative humidity, operative temperature in the space, and the wind velocity. And after having those information, we've been able to consider how much saving we can get from cooling, from natural ventilation for cooling, and how we can, more importantly, I mean, that was the integrated delivery advantage of like having energy and MEP at the same time. We've been able to optimize our hybrid controls for the hybrid mechanical system. And again, the energy analysis in this job was definitely challenging because of the stringent goal of achieving net zero. More than 66% of the energy in the project was coming from miscellaneous equipment, and out of that 66%, 82% actually comes from the kitchen equipment. So the kitchen equipment, modeling energy, kitchen equipment, modeling every single of them accurately with the most accurate schedule that we could find from other McDonald's projects was the key, and helped us a lot to be able to make a good predictable energy simulation. But at the same time, we looked into envelope, glazing, HVAC system, natural ventilation, and other energy cost measures to optimize the energy efficiency. Regarding the UN Sustainable Development Goals, this project, we believe that indirectly is meeting and advocating for so many goals that have been defined by UN, but definitely the clean energy goal 7 was achieved through including the PV canopy and offsetting all those carbon emissions that in a regular life we had to get that from the grid and the source. Climate action, this project is contributing a lot by reducing the carbon emission, and is setting an example for the entire market that for a commercial kitchen and high energy use intensity project, if this project can go net zero, any project can go net zero. And definitely, like other area, this project was good health and well-being with natural ventilation. The project is improving the air quality, and is with the outdoor activities, the green walls, sufficient daylight, many elements of the healthy building being achieved in this project. The key innovation in the job, we believe that our integrative design delivery between the MEP and the energy analysis helped the project to achieve a doable, feasible, practical, automatic operable window system that works with the hybrid mechanical system in the job. And the BIPV panels and creating this pleasant outdoor dining area that we see here was another innovation in the job. And most importantly, electrifying such a huge kitchen being a big challenge and innovation that it's probably one of the earliest of like the electrification. We hear a lot from that, but electrification of such a huge kitchen is definitely another level of challenge. And this project been able to achieve and eliminate any use of gas on site. So this project is pursuing ILFI Net Zero International Living Future Institute Net Zero certification. And that means that annually, this project should exceed the energy consumption that it has on site by the PV generation. That's why the energy analysis and the exercises being shaped around predictive energy analysis. And in the diagram below, you see what fraction of the energy comes from the different end users. And again, the kitchen equipment, and after that, the space cooling, exterior lighting are being the biggest end users in the job. The big takeaway is we have seen net zero projects in residential and the commercial world, but by making such a building net zero, we believe McDonald's is setting an example for the market that net zero is doable and is achievable, and it should be pursued more, electrifying the kitchen and minimizing the use of gas that help us to reduce carbon emission is another takeaway from this job that, again, like it should be used as an example to help all other chains and commercial restaurants to know that we are using a lot of gas in the commercial kitchens and even in the residential kitchen, and electrifying the kitchen makes an important role in fighting climate change and reducing carbon emission in the project. So with that, we now can move on to the Q&A session and answer your questions.
Thank you, Mohammad and Joe, for a fantastic presentation. So before moving into the Q&A period, I would like to remind attendees to enter your questions in the question box on the GoToWebinar platform, and also you can download a PDF version of the presentation from the handout box on the dashboard. We'll start with the first question. What were some of the technologies you considered but didn't use?
Well, for this particular project, we really started out throwing out a lot of different technologies that we thought would be successful. We did a little research, from solar chimneys, which would be a draft-inducing situation, more common in the American Southwest, which that was quickly dismissed, to geothermal was the one that we considered heavily, which would be a large well field underneath the parking lot that would reject and draw heat from the groundwater and the ground below the restaurant, and then we could use that to as our energy sink, our heat sink for the air conditioning system. That was rejected because of the general ground temperatures of the Orlando area. It just didn't come out very feasibly. We thought we would end up heating up the water without grossly oversizing the well field. We were afraid that we would we would heat up the ground so much that we would not be able to reject any more heat into the ground. So we took that away. Also, we would have had to tear up most of the existing parking lot, and that was cost prohibitive. Believe it or not, even cost was considered on some of these options, and that was considered very cost prohibitive for this application.
Thank you. The next question, what was the most creative or out-of-the-box solution provided to the client from an electrical design perspective?
One idea that been considered and came from different direction on the electric side, as I mentioned, the kitchen equipment being the biggest challenge. So the smart controls for the kitchen equipment being considered and came from a different direction, that when we are not using the grills or fryers, we can have a smart control that turn it off, and that could be a really effective energy efficiency measures, but for a couple of reasons didn't end up including in the project. But that's something that apparently McDonald's has on their horizon to use for the upcoming next project that they have. So that's going to be another thing to consider to further optimize such a project.
Thank you. Next question. Did you take into account life of equipment and if they are able to be repaired when considering the various equipment and kitchen appliances?
We did generally the kitchen equipment and the appliances. We did look at that a little bit. However, McDonald's tends to go through equipment pretty quickly. The pieces that they purchase are high quality, but they use them a lot. So this equipment was not necessarily more or less reliable than the standard kitchen fit out. However, and for the HVAC, the mechanical and electrical plumbing pieces, we used pretty much off-the-shelf equipment. So VRF systems have a 15 to 20-year lifespan, especially under a roof and a canopy like we have. The outdoor equipment should be fairly reliable through that time and well protected. We used heat pump hot water, domestic hot water systems with a large storage tank. Those are fairly reliable and very well maintainable pieces of equipment. So we didn't do anything that was on those sides too outside of the box that we would run into supply chain issues further down the road.
Thank you. Next question, what was the difference between a designed performance and actual occupancy performance?
I can answer that. I mean, that's what we don't know. Like as I mentioned, we have used different sources of data, the transactions of the current restaurants, even the Google occupancy schedule to understand and predict what's going to happen. But and we usually have two approaches. Sometimes we do comparable energy analysis compared to codes, but in this case, we did our effort to make it a predictive energy modeling, but still, we anticipate that there are going to be some gaps between what we anticipated to be an energy use and what's going to be there. We are still waiting to see some results, but definitely the pandemic and the change in the schedules gonna impact that. And that would be interesting to see how that impacts the energy. But that's something that we anticipate there are going to be some gaps based on different factors like pandemic, different events in the area, even different season. A lot of things can go wrong or different that change. And one thing that I have to mention, like, is even the climate. If because of climate change we get a high peak load in the summer that it wasn't part of the climate file that we used, that could also like change the energy consumption in summer. I mean, we did consider some of the future weather files for some of our analysis, but definitely the main weather file that being used was the average of the past 10, 20 years. So that's another area that we believe that it could go different than how we analyze that during the design.
Thank you. Do you think these measures and projects McDonald's will be looking to implement in other buildings in the future, and how transferable in the project given their size?
Well, given there are parts and pieces, and McDonald's tends to renovate. Both franchises and corporate-owned ones tend to renovate and change over their designs on a fairly regular schedule to upgrade and account for new technology. As the push moves towards more electrification, I believe the big part for decarbonizing our economy would be that McDonald's would move away from a lot of gas-fired cooking appliances and more towards all electric systems, so that they could rely on either locally produced or grid supplied renewable energy. Would be one discussion and one big application. Also, a market force like McDonald's, they really would be a market mover in terms of bringing locally sited power and on-site generation, both for their local piece and also to try and achieve net zero, as would be something that could be applied, maybe not with canopies this dramatic, but it could turn into something that could be integrated into their standard design. I don't know if you seem to notice that they all start to change over from the old Gansered roof wood shingle McDonald's of 20 years ago to something more of a gray and brown wood-sided box. now. And so as the next iteration of the design standard comes out, that might be something that could be integrated. We'd have to continue to discuss with McDonald's, but those would be things that they could take on as lessons for future designs.
Thank you. We don't have a lot of time. We will take the last question. There are additional questions, but unfortunately, these will be answered directly by email. Did the client owner have any pushback or concerns regarding the approaches you underwent?
I can take this. McDonald's actually really was pushing the cart more than we pulling it. It was they were a great client to work with because they wanted to see what we could do. I mean, we put in natural ventilated kitchen equipment and tried to naturally ventilate their whole dining area, which is a pretty aggressive move, and they were really looking for it. We did look at a solar thermal array for the hot water. They were a little leery about that for operations and making sure that they had sufficient hot water. And so we moved away from that approach because that was another design system that they would have to maintain. And also some of the more aggressive cooking operations and controls that we wanted to implement were pushed back a little bit just to make sure that they could provide the user experience that McDonald's wants to maintain. And so those were the big pushbacks, but in general, they listened and they had very good questions and wanted to hear what we were going to do, and they were willing to run with any solutions that we came up with that we stood behind, I guess.
Fantastic. Thank you. Thank you for a fantastic presentation, Mohammad and Joe. We're at the end of our webinar session, so please feel free to follow up directly with the contacts shown on the screen. And I would like to thank all attendees for joining today. I appreciate your time. Thank you very much, everyone. I will wrap up the webinar now. Thank you.
Okay, thank you.